The scatter plots below show the relationship between height, diameter, and volume of timber in 31 felled black cherry trees. The diameter of the trees is measured 4.5 feet above the ground. So here's some, seems like real life data. And this is how it comes out looking from many statistical software packages. So what you might see if you read a professional, a study in a professional job of showing some data here. So, okay, so notice something about the graphs first off. This graph right here, change up my color so it shows up better. This is volume and height for this graph. And this graph down here, it's volume and diameter. You see the difference there? We're talking about trees, felled black cherry trees. So you got a tree. I'm going to try to draw a tree. Yeah, that's not going to work. My artistic weakness is great. So basically, they're taking a tree, and I'm trying my best. So we got a tree, okay, and we're cutting it down. So we're just taking a piece of it, and there's basically how high the height of the tree. The higher the tree is, the more volume of wood you get from it, right? Taller trees that you cut down are going to have more volume of wood, more amount of wood. Whereas another indication is trees that are wider. So all the way, here, let me back that up. All the way across the tree, the diameter is how far across the middle of the tree. So trees with bigger diameter tend to have more volume, right? Higher diameter is connected. Well, let's just say higher diameter makes higher volume, right? The diameter is like thickness. So the thicker the tree, the more amount of wood you're going to get from it. But also, the more height, the taller the tree is, you're also going to get more volume of wood, right? Taller trees give you more wood, and thicker trees give you more wood. That's what these graphs are showing. And see how the dots kind of go up in a line a little bit? And these ones really go up in a line, don't they? Okay. So you guys tell me as you look at this, let's go to the sentence. Describe the relationship between height and volume. So which graph is that? That's the top graph, height and volume. So it looks like there's a positive relationship, doesn't it? Doesn't it look like you could sort of fit a line through the middle here? Now, it's not a very tight line, but it does look like those dots kind of go in a line pattern up to the right. Again, not very tight, but a little bit. We'll just kind of leave it at a little bit. Whereas the this one right here, for the diameter, this is a very tight line. This is definitely a line going up. And it makes sense that these relationships would go up, because as you go up in your height, you tend to go up in your volume, right? More height is more volume. Taller trees, see how these dots tend to go up to the right? Because trees of more height, higher height, tend to have more volume. You see that? So that's why the line goes up. Same thing with this line. Why this line goes up is because as you go up on the x-axis is diameter. Higher diameter makes higher volume. You tend to go up on the y because the y-axis is volume. The dots tend to go up. Of course. Okay, so what would we say there? How would we answer this question? Describe the relationship between height and volume. Strong positive, weak, moderate positive. Well, to me, that looks weak positive. It's not strong. The dots are not super strong, not super tight. So it's weak. Dots are not tight. And that's for height and volume. Whereas down here, they're asking us diameter and volume, which is this graph right here. And the dots are very tight, very tight. So that's going to be strong positive. Tight dots, very strong relationship. And then the final question, suppose you have height and diameter measurements for another black cherry tree. Which of these variables would be preferable to use to predict the volume of timber in this tree using a linear regression model? In other words, in both cases, the y-axis is volume. Do you see that? It's volume in both cases. So which measure, height or diameter, is a better predictor of how much volume of wood you're going to get out of the tree? It's going to be diameter. Why? Because the dots are tighter. There's a stronger connection between diameter and volume than there is between height and volume. Do you see what we're saying here? Of course, taller trees have more volume of wood, and thicker trees with a bigger diameter also have more volume of wood. But diameter is a better predictor according to this data. These dots are tighter, which means if you want something that's going to predict for you, going to tell you how much wood you're going to get when you cut down a certain tree, rather than looking at how tall the tree is, you should look at how thick the tree is, the diameter. That's a better predictor because these dots are tighter. It's a better predictor. Whereas height, the dots are kind of spread loose, meaning you can have tall trees, but they're kind of slender, and so there's not that much wood on them, Whereas diameter, that pretty much tells you how much wood you're going to get. Diameter, the dots are tighter. That's a better prediction on that. So the stronger relationship there tells us diameter. That's the stronger relationship. The dots are tighter, which means diameter is more closely connected. Stronger relationship to volume. Diameter connects to volume better than height does, is what we're seeing from that. So there we go.